Welcome to Physics Unwrapped YouTube channel. In today's video, I'm going to solve previous year question paper on tensor that comes under Mathematical Physics unit. I'm going to solve the question paper starting from 2013 to 2025 present. Yes, let us start with the first question. What does the question says? Which of the following is not a tensor? So, from the definition of a tensor can be a vector and even tensor can be a scalar. A tensor can be a vector which is having a rank to be equal to 1. A tensor can be a scalar whose rank is equal to 0, that is order to be 0. Okay. Your velocity, acceleration and the gradient of a scalar field and your mass all belongs to vectors and scalars, right? But what they have asked, which of the following is not a tensor? All are tensors only. Okay, now the correct option is they have not mentioned it properly. So all are correct option only. There is no wrong option. Okay. Yes. Let us move with the next question. The next question is if A mu and B gamma are components of contravariant and covariant vectors, what is the nature of the quantity, that is A superscript mu and B subscript r? Okay, so what is the nature? They are asking, is it a zero, an invariant, a contravariant tensor, a mixed tensor of rank 2? I'm ticking to option D. It is a mixed tensor of rank 2. Why rank 2 means, can you see the indices, that is mu and here it is r. I don't know, here they have mentioned here gamma. So it is A mu and B gamma, what we call this mu and gamma or the indices. This mu and gamma are two different indices, right? So I can say it is having a rank 2. Okay, and this is a mixed tensor. Okay, this is the example of the mixed tensor. This is a way to write the mixed tensor. Okay, so it is a mixed tensor of rank 2. Yes, now let us proceed to the next question. A receipt tensor, that is r subscript mu r, what is the quantity? G subscript mu r. This is, if you found small g means this represents it is a metric tensor. Okay, in the summation convention. So from the definition of the receipt tensor, I can directly tick to the option, it is a scalar curvature. From the definition itself, what is the quantity? G mu r in the summation convention, it is a scalar curvature. Okay, yes. Let us proceed to the next question. What we have in this question is subscript ij and aij represents a symmetric and an antisymmetric real value tensor respectively in 6 dimensions. The number of independent components of Sij and Aij are. So there is a formula to find the independent components in symmetric tensor as well as antisymmetric tensor. And here they have mentioned it is a 6 dimensions, right? Now the formula is for anti-symmetric and symmetric. Now for symmetric, the number of independent components can be found out using the formula n into n plus 1 divided by 2. For antisymmetric, n into n minus 1 divided by 2, where n is called the dimension. Okay, here they have given it to be 6. Now substitute. So it here it will be n is 6. 6 into 6 plus 1 divided by 2. 2 ones are 2 threes are, so 7 threes are 21. Here it will be n into n minus 1, that is 6 into 6 minus 1 divided by 2. 2 ones are 2 threes are 6 minus 1 it is 5. 5 threes are 15. 21 and 15 is the right answer. That is, first they have asked the symmetric, then they have asked the antisymmetric. So the right option is option B, that is 21 and 15 respectively. Okay, next question. Now what we have in this question, the Kronecker delta, delta ij. This is a representation of the Kronecker delta, that is delta ij. It is a mixed tensor. The value will be 1 if I, which is equal to j, and value which is equal to 0, I not equal to j in three-dimensional Cartesian coordinate system transforms like, and it represents like a tensor of a rank 1, a tensor of a rank 2, an axial vector and pseudoscalar. This is delta ij. Here I and j are the two different indices. If we have two different indices means it is a rank 2. It is a tensor. They have not given what kind of a tensor. It is a covariant or a contravariant or a mixed. So according to the definition, it is a mixed tensor of rank 2. Okay, mixed tensor of rank. Okay, so which is the right option? Option B is the right option. Yes. Let us proceed to the next question. What we have in this question? Two tensors are said to be reciprocal to each other if their inner product is equal to, if their inner product is equal to unit tensor. Means how I am doing this questions means if you have a little knowledge about the matrices, you can easily attempt the tensor question. What they are asking here, the two tensors are said to be reciprocal to each other. Let us consider two tensors, that is A and B, that is reciprocal to each other means A can be written as B inverse or B can be written as A inverse, like that. Okay, now A into B. Two tensors are said to be reciprocal to each other. The inner product, that is A into B, is equal to unit tensor. That is, our means B can be written in terms of A inverse. A inverse is nothing but 1 divided by A. A get cancelled. What is remaining? 1. 1 is nothing but the unit tensor, right? Yes. So I will tick to the option B, that is a unit tensor. Next, let us proceed to the next question. That is question number 7. Two tensors are called conjugate tensor if they are, from the definition of the conjugate tensors are nothing but the metric tensor. Now metric tensor is a symmetric tensor, and from the definition of the conjugate tensor, it is also a reciprocal. Okay, which is the right option from the definition of the conjugate tensor? It is a symmetric and it is reciprocal. Okay, yes, let us proceed to the next question, which is the question here. If TJI is a second rank mixed tensor, it transforms under the coordinate change. Xi changes to X bar J as. Okay, now what they are asking, transformation. They want the transformation. So how it transforms, that we must study. So it is T bar, in the subscript we have beta, in the superscript we have alpha. Now this alpha, if it is in a subscript, it represents, if beta it is in a subscript, this is alpha in a superscript. Alpha in a superscript means that represents it is a contravariant tensor, and beta is in a subscript, it represents a covariant tensor. So from the definition, what is contravariant and what is covariant, I am writing of a rank 1. Okay, contravariant tensor. Okay, how can I write contravariant tensor? Means A bar J, which is equal to dou X bar J divided by dou X I into A I. From the definition of the contravariant tensor, this is the representation of a contravariant tensor of a rank 1. Now, from the definition, covariant tensor can be written as A bar j, that will be in a subscript, which is equal to dou x to the power of I dou x bar j a I. Okay, from the definition, this is the definition of the covariant tensor. Okay, using these terms, we can build the transformation here. First, we will see it for a covariant tensor, a contravariant tensor, that is alpha. So it will be dou x bar alpha divided by dou x I. Next, for the covariant tensor, it will be dou x j divided by dou x bar beta from the definition into t j I. So which option is the right option? From the options I can say option B is the right option. Just compare and see. This is transformation is quite easy when you go step by step. First you need to do the transformation for the contravariant, then you need to do the transformation for the covariant. uh like how the coordinate changes, they have given how the transformation is done. Using proceeding with this, we can do this, and it is very simple. Okay, yes, let us proceed to the next question. If the line element of the space is given by ds square, which is equal to dq square plus 4 times of dq1 dq2 plus 3 times of dq2 square, the metric tensor is. So the metric tensor representation represented by g1 and 2 you can write, or gij you can write. It is your wish. The indices can be anything. Now this is a metric tensor. It is a tensor of a rank 2, I can say. Means how in the matrix how we can write. For example, I'm going to rewrite this in terms of a x and y component. Okay, here they have given in terms of q1 and q2. I'm going to write in terms of x component, that is dx squared can be written as 2 times of dx whole square plus 4 times of dx into dy plus 3 times of dy square. Okay, so this dx square can be written as dx prime square plus 4 times of dx1 dx2 plus 3 times of dx prime square. Like this also we can write, or in terms of a matrix. So instead of dx, here it will be 1 1 component, here 1 2 component, here 2 1 component, here it will be 2 2 component, right? So 1 1 component it will be 2, and 1 2 component and 2 1 component, these are one and the same. So this term what we need to do means we must divide it by 2 and then write it separately. So it will be 2 1s are 2 2s are. Here it will be 2, here also it will be 2. This is 1 2 component, here it will be 2 1 component. For both it will split the given term, the line element of the space will split like this. Next, as it is 2 2 component, it will be 3 only. Okay, this is g1 2, that is a metric tensor. So it will be 2 2 2 3, which is the right option. Option C is the right option. Let us proceed to the next question. What we have in this question: if AKIJ is a third rank mixed tensor, it transforms under coordinate change. Coordinate. It is a similar question. Last time it was asked for rank 2. Now it is asked for rank 3. It is easily you can do. Now from the options only we can eliminate. 2 times it is contravariant, 1 times it is covariant. Contravariant. So this will be eliminated and this will be eliminated, right? And even this will also be eliminated. So which is the right option? This is the right option. By looking at the options only we can see. The last example I have explained, Uh, Doing the same way, we can proceed with example. Option B will be the right answer. Okay. Yes, let us proceed to the next question. These questions are repeated questions from the previous year question papers. Yes, the number of independent components of a real antisymmetric tensor of rank 4, rank 2 in 4 dimensions. So we should not think about the rank, only we want the dimension. What they have given, real antisymmetric tensor means the formula is, and I have written already, n into n minus 1 divided by 2. So here n represents a dimension. Dimension is 4. 4 into 4 minus 1 divided by 2. 2 ones are 2 twos are. So 2 threes are 6. Option B is the right option. Yes, let us proceed to the next question, which was recently asked in 2024. This was asked in 2020. Yes, let us proceed. The same question they have asked, the number of independent components of a symmetric tensor with indices ij that is equal to 1, 2, 3. 1, 2, 3 they have given, no, we can find out that is n which is equal to 3. Means 3 dimensions and it is having a rank 2. Nothing to do with the rank, only we need to proceed with the dimensions. The formula is n into n plus 1 divided by 2. So n which is equal to 3 into 3 plus 1 divided by 2. So it will be 3 into 4 divided by 2. 2 ones are 2 twos are. So correct option is, the answer is 6. The correct option is 3, that is 6. Yes, I hope everyone is clear with these questions. I have solved complete the questions which was asked from the previous year questions, that is 12 questions. Uh, Thank you for watching. For more videos, you can visit my YouTube channel, that is Physics Unwrapped.